So in this lesson, we're going to look at some applications of similar triangles. So we're taking the skills that we picked up in the last section where we were working with similar triangles and solving for the lengths of unknown sides. And we're going to apply this to situations where they basically just give us a description of the situation. So we want to be able to solve word problems that involve solving for the unknown sides in similar triangles. So we'll start off with one like this where they give us a diagram to work with. Surveyors are trying to measure the width of a canal. Rather than cross the canal, they laid out the following triangles and made measurements on one side of the canal. How wide is the canal? So what are they asking us to find? Well, on our diagram, we want to find how wide is the canal. This is our canal right here, and the width of the canal, let's just mark it as W down here. So we want to find this distance across here. So sort of the length of this side in our triangle. Okay. Now, we can kind of assume that these triangles are similar, but just to be on the safe side, the first step we should do in when we're approaching this kind of question is we should figure out which angles are equal to each other. So let's just go ahead and we'll label the equal angles in our two triangles. We do that to show that the triangles are similar, and it also leads us to the next step where we are going to match up our corresponding sides. And having the angles labeled helps us do that. So corresponding sides. All right, so which angles in our triangle are equal? Well, we've got two of them given to us right off the bat. We've got a right angle right here, and we've got a right angle right here. So we know that those two angles have to be the same. And also, this angle here and this angle here are opposite angles on opposite sides of that point of intersection. So they have to be the same as each other, which means this angle down here and this angle up here have to be the same as one another. Now we can start labeling our corresponding sides because we know that corresponding sides go between two angles that are equal. So the width, the one that we're trying to find, goes between the right angle and the one that I've marked with the arc. So it corresponds to this angle up, this side up here in our small triangle. Similarly, if we look at the one between the arc and the dot is going to be that one right there, and then this one and this one must be corresponding sides. So once we have the corresponding sides, we can set up our proportion. Well, let's actually write the words here. Let's say we're going to set up proportion. And then, of course, once we have our proportion, we just have to solve for the thing that we want to find out. So as before, let's set this up with things from the small triangle on the top and things from the large triangle down on the bottom. So what do we have here? In the small triangle, we have a side that is 7 meters. The corresponding side in our big triangle, we have labeled as W. Also in our small triangle, we have this one side that is 15 meters that I marked with the little squiggle. The corresponding side in the big triangle is 45 meters. We've also got the two sides that are marked with the X as corresponding sides, but we don't have dimensions for either of those, so we can just kind of ignore it. All right, now we just have to solve our proportion here. So we are going to cross multiply. 7 times 45 is going to give us 315. Is going to be equal to 15W. And then, of course, we just have to divide both sides by 15 to figure out what W is. Looks like W is going to be 21. So we can sum this up with a little statement at the end. Therefore, the canal, I'm not sure what happened to that end there. Let's say the canal is 21 meters wide. Okay. And writing this statement at the end just helps it just helps you to show that you understand that you found the thing that you want to find and what it represents in the context of the question. All right, let's try a second one here. A 5-meter tall flagpole casts a 4-meter long shadow at the same time of day as a building casts a 30-meter shadow. How tall is the building? Well, this one's a little bit trickier because they don't give us the diagram to work with. So we're going to have to draw the diagram ourselves here. So this is going to be the ground. I'm going to put our building over here. We don't know how tall the building is. And I'm going to put our flagpole right over here. And what we know is that the sun is shining at some angle. So our flagpole is going to cast a shadow down here like this. And I guess I'll just sort of highlight this shadow here in blue. And our building is going to cast a shadow like this. And so this is going to be the shadow of the building. So this is our flagpole. This is our building. Now, what information are we given in the question here? We are told that our flagpole is 5 meters tall and its shadow is 4 meters long. So this shadow down here is going to be 4 meters long. At the same time of day as a building casts a 30-meter shadow. So the building shadow is going to be 30 meters long. We want to find how tall is the building. So we want to find this distance here. We'll call this h for the height of the building. Now, they don't tell us any of the angle information, but we know that our flagpole is going to be perpendicular to the ground, and our building is going to be perpendicular to the ground. And if the sun is shining down on both of these things, like this side right here is parallel to this right here because these kind of both represent the lines of the shadow coming down. So this angle in here and this angle in here are going to be the same. Okay, the shadows are going to make the same angle with the ground, which of course means that this angle and this angle are going to be the same. So we've got our angles that are the same. We can start matching up our corresponding sides. And this is pretty much done for us already. We know that this side and this side are going to be corresponding. We know that our two shadows here and here are going to be corresponding. And finally, this side and this side are going to be corresponding. So we can set up our proportion here. Small over large. In our small triangle, we have got a side that is 5 meters, and that corresponds to h in our big triangle, both marked with the squiggles. In our small triangle, we have a side that is 4 meters. That corresponds to the 30 meters in the big triangle. We don't have anything for either of the two sides that are marked with a circle, so we'll just leave it. We are going to cross multiply and divide. So 5 times 30 is 150. It's going to equal 4h. Dividing both sides by 4, h is 37.5. So the building is 37.5 meters tall. All right, here's one that's a little bit trickier here. To find the height of a tree, Sarah placed a mirror on the ground 15 meters from the base of the tree. She walked backwards until she could see the top of the tree in the center of the mirror. At that position, she was 1.2 meters from the mirror, and her eyes were 1.4 meters from the ground. How tall is the tree? Well, they've given us a diagram here. This clearly is our tree over here. And over here, this is obviously Sarah. And in between the two of them, right here, is the mirror. So Sarah can kind of look, if we'll use blue here to represent sort of her line of sight. If she looks down, she sees the mirror and she sees this ray of light sort of reflected from the top of the tree, it reflects off the mirror right into her eyes. Okay. So we've got our diagram like this. Let's take the information that they give us and add it to our diagram. So it says, well, what do we want to find? We want to find how tall is the tree. So this is how tall the tree is over here. We'll label this with the letter H. What information do we have? To find the height of a tree, Sarah placed a meter on the ground 15 meters from the base of the tree. So from the base of our tree out to the mirror is going to be 15 meters. She walked backwards until she could see the top at that position. She was 1.2 meters from the mirror. So she is 1.2 meters from the mirror, and her eyes are 1.4 meters from the ground. So 1.4 meters over here. Okay, let's match up which angles are equivalent to each other. So this is a right angle, and this is a right angle. We know, if we know a little bit of physics, we know that if for a reflection in a mirror, the angle of incidence is equal to the angle of reflection. So those two angles are going to be the same. And that means that this angle up here and this angle in here are going to be the same. So we can match up our corresponding sides. The two sides that I've already drawn in blue are going to be corresponding because they go between the angle with the dot and the arc. Our two vertical sides here are going to be corresponding because they go from the dot to the right angle. And lastly, this side and this side are going to be corresponding because they go from the right angle to the angle marked with the arc. So we can set up our proportion here. Let's do, again, small over large. In our small triangle, we have got a side that is 1.4 meters, marked with a circle. That corresponds to H in the large triangle. In the small triangle, we have a side that is 1.2 meters. That corresponds to 15 meters in the large triangle, because they're both marked with a squiggle. All right, and that's all we need. So we can cross multiply. So we're going to have 1.2h, and then 1.4 times 15 is going to give us 21. And then we divide both sides by 1.2. Our height is going to be 17.5. So what does this represent? It represents the height of the tree. Therefore, our tree is 17.5 meters tall.